Arkadaşlar, in this video, I will solve several discrete time Fourier transform examples, and I want you to exercise on these kind of problems to learn more about discrete time Fourier transform. Here you see one discrete time system, and the input is, as you can see, our input is x of n, and our output is y of n. And we have the impulse response of h of n. We have a sum adder here. It takes the summation of the inputs. This is a delay unit, okay? It's called S, delay unit. And then B is the multiplication. It's like multiplies the input and obtain B times something, okay? So when I look at this problem, I see that I have this input x of n here, and then to the other, I obtain, this is my y of n, and times b, which is like b y of n, and I will add these two, and I will obtain x of n plus b y of n here. And then there's a delay unit, which takes the delay of this one and this one separately, and finally I will have x n minus 1 plus b n minus 1 will be the output here, and it is also equal to y of n. So that's why I would like to write now the difference equation that we have found, x n minus 1 plus b y n minus 1 equals y of n. Okay, so I added x of n and what b y of n, and then I take a delay. This is one sample delay for x of n and b y of n. B is not affected by the sample because it's just a multiplication, and I multiply these two and then obtain x n minus 1 plus b y minus y n minus 1 equals y of n. So this is my difference equation, arkadaşlar, difference equation. Now it explains the relationship between the input and the output, okay? So here, if I have x n minus 1, and on the other side, y n minus b y n minus 1, this is like the relationship between the input and the output. Okay, so A is done. B, determine h e to the j omega, the frequency response. How do I find it? I make a change from time domain to frequency domain. X of n is Fourier transform of x of n is x e to the j omega. If you think about x n minus 1 as my function, then I will have x e to the j omega times e to the minus j omega. Okay, from the properties, if there's a time shift here, it means there is a phase shift in the frequency domain. If you think about y of n, its Fourier transform is y e to the j omega. And if you think about y n minus 1, its Fourier transform is again y e to the j omega times e to the power minus j omega. Okay, by using these information, now I'm going to focus on this equation, and I'm going to put these findings, such as x e to the j omega times e to the minus j omega is equal to, now I'm going to write this one, y e to the j omega times, or sorry, minus b y e to the j omega times e to the power minus j omega. Okay, I hope you understand this part. It's easy. I just wrote the Fourier transform of this part, Fourier transform of this, and Fourier transform of this, and multiplied by b here. So this is the relationship in frequency domain. Now I'm going to write the frequency response, which is h e to the j omega, which is y e to the j omega divided by x e to the j omega. So I need to write h right now. How should I do it? Write y on one side, x on one side, then arrange the numerators and denominators, and finally I will find out the solution, okay? X e to the j omega, e to the j omega, y e to the j omega, this is my parentheses, and then 1 minus b e to the power minus j omega, okay? Y times 1 is this one, y times b to the j omega is this one, okay? So finally, I would divide both sides by x e to the j omega, and then this will go away. And this part is h e to the j omega. And then this thing will go down. And finally, I will have h e to the j omega is equal to e to the power minus j omega divided by 1 minus b e to the minus j omega. Okay, this is what we can say about h e to the j omega. So the b part of this question is also done. This is the frequency response of my system. H of n is the impulse response. So from here, I should go to find h of n. This is the question. How should I do? I don't do any integrations or anything like that. Instead, I look at this one. If my function would be 1 over 1 minus b e to the power minus j omega, then the Fourier transform would be b to the power n un, right? So if this was my signal, then I would write b to the power n un e to the power minus j omega n, right? From n is equal to minus infinity to plus infinity. Now I'm doing a kind of double check if the Fourier transform of this one is this one, okay? So I want to show that this is the reality. So un will affect this one, and this will go to 0. Now my function, my summation will be from 0 to infinity, b e to the power minus j omega, and then the power is n. So this is now my b, my alpha, and then from 0 to infinity, alpha to the power n is equal to 1 minus 1 over 1 minus alpha. So alpha is b e to the power minus j omega, and you can see that this is correct, okay? So I can say that if b to the power n un would be my h of n, its Fourier transform would be 1 minus 1 over 1 minus b e to the power minus j omega. What was the original frequency response? So I have 1 e to the power j omega property. So if I multiply e to the power minus j omega times, let's say, t of e to the j omega, if this was my t e to the j omega, okay? So what does this mean? This means I have a shift of -1 samples. That means u of n b n to the power b of b to the power n minus 1 u n minus 1. Okay, I use the property here. If there is a shift in the phase, then it means there is a multiplication e to the power j something. It means there is a one sample shift. Okay, so what is h of n arkadaşlar? H of n would be b to the power n minus 1 u n minus 1. Okay, so this is the impulse response. How do I plot this arkadaşlar? Let me plot it starting from 1, then 2, 3, 4, and so on. This is my n. For 1, it is b, it is 1. For 2, like b to the power 1 minus 1 is equal to b to the power 0, which is 1. b to the power 2 minus 1 is equal to b to the power 1, which is b, and then b squared, b cubed, and then b should be, it should be, actually b should be less than 1 here. If b is a negative number, if it is like between -1 and 0, then it would be something like that. B okay, so if b is less than 0 and greater than -1, this would be my plot. If b is greater than 1 and greater than 0 and less than 1, then this would be something like that. So it all depends on our b. For example, if I ask you, is this system stable or causal, how would you approach to this problem? I would check h of n, okay, b n minus 1, u n minus 1. How would this system be stable? If b is less than 1, okay, if the absolute value of b is less than 1, then the system would be stable, because the addition of this or this would converge to the addition of h of n would be less than infinity, okay, because it will converge to one value. And this system is stable, whatever, the system is causal, whatever b is, h of n is 0 for n less than 0. That is why this system is causal. Okay, so I hope this part is clear for you. I want to stop here and I will go with another video for another exercise.